Hey guys, it's Mr. Tracy. We are going to be picking up where we left off before the quarantine, which is quadrilaterals. Alright, we've banged out most of them. We just have one left that we have not talked about, and that is the good old trapezoid. Alright, so we're going to be doing that today. We'll take a couple of notes, we'll do a couple of problems, and then you guys are going to have a homework assignment that is attached to the assignment on Teams. All right. You could also find this page of the notes there, so if you have a printer at home, you can print them out and follow along. Otherwise, I would take these notes using a regular piece of paper or in a notebook if you have one. All right. So to start, there are two types of trapezoids. We have non-isosceles trapezoids, and we have isosceles trapezoids. Okay, you guys should be familiar with what the word isosceles means. All right, so think about what that is, and then we will come back to it. But we're going to talk about non-isosceles trapezoids. And the one thing that separates a trapezoid from all of the other quadrilaterals that we've talked about is that non-isosceles trapezoids have only one pair of parallel sides. Okay, so in this isosceles trapezoid up here, okay, we have two sides are parallel, and we have the other two sides which are not parallel. That goes for all trapezoids in the history of the universe. All right. Now, I told you to think about what the word isosceles means. Okay, you should remember that from when we did triangles. All right, isosceles trapezoids are a little bit different. Yes, they also have one pair of parallel sides. I'm going to abbreviate. Just like the non-isosceles trapezoid. But think about what isosceles means. Remember, isosceles means that we have congruent sides. Just like an isosceles triangle, remember these guys? Have two congruent sides. An isosceles trapezoid also has a pair of congruent sides. Okay? So if you see the word isosceles trapezoid, remember we have two sides that are congruent. Now, think back to triangles again. When we had an isosceles triangle, we remembered that the two sides are congruent. Okay? There was one other property about isosceles triangles. Take a second to see if you could remember. Remember, if these two sides are congruent, these two angles are also congruent. The same thing goes for isosceles trapezoids. If these two sides are congruent here and here, that means these two angles, which I know all of you remember are called the base angles, these two angles are congruent also. So an isosceles trapezoid, just like a triangle, has a pair of congruent sides, and it has a pair of congruent angles as well. All right. One other thing about an isosceles trapezoid is that if these two sides are congruent, that means, what are these called? Starts with a D. The diagonals. The diagonals are also congruent. Okay. So far we have two sides are congruent, we have two base angles are congruent, and we have the two diagonals of the trapezoid are also congruent. Okay? And the last thing that you need to know about isosceles trapezoids is that the opposite angles are, who remembers this word? Supplementary. Take a second to remember what supplementary mean. That's right, they add up to 180. All right, so the only other thing that we really need to talk about isosceles trapezoids is when we have the median of an isosceles trapezoid. Okay, the median of an isosceles trapezoid connects the midpoints of the legs. This is actually supposed to say mid-segment. Sorry guys, that was just a typo. Okay, the mid-segment of an isosceles trapezoid connects the two midpoints of the legs. Okay, so think about it. In this particular trapezoid here, it says if EF is the midsegment of trapezoid A, B, C, D, then we know two things. All right, take a second to look at this trapezoid and tell me what two sides are definitely parallel to each other. Remember, parallel means if we extended them forever, they would never ever intersect. This is our sign for parallel. Okay, so BC would be parallel to what side? Well, if you said AD, you would be correct. And also, the midsegment is parallel also. All three of these sides here are parallel to each other. All right, so if EF is the midsegment of this particular isosceles trapezoid, then we know for a fact that AD is parallel to EF, which is parallel to BC. All right, we have three parallel parts of this isosceles trapezoid. I keep wanting to say triangle. All right, and last but not least, okay, last but not least, if this is the midsegment of the trapezoid, if I wanted to figure out how long EF was, it's pretty easy. Since this is halfway up and halfway in between BC and AD, okay, if I take the two sides, BC and AD, and I add them together, if I divide that sum by 2, I get the length of the midsegment. Okay, so it's basically just like finding the average between the two sides. Okay, BC plus AD equals EF. All right, so those are all of the things that you need to know about a trapezoid. So now we are going to apply them. All right, on the next page I have a couple of problems. All right, first one. It says for trapezoid ADON, I and S are the midpoints of the two legs. Find the measure of YZ, and YZ does not exist in this trapezoid because Mr. Tracy is silly. I really wanted you to find the measure of IS. Another little typo, sorry guys. All right, so what did we say? If we have to figure out what's the length of IS, that means I definitely need to figure out what X is. All right, well, I have enough information here to do that because remember from the first page, if I want to find the length of the mid-segment, which is IS in this case, I could add up these two sides and then chop it in half or divide by 2. Okay, so the sum of the two sides here divided by 2 would be the length of IS. So take a second and think about what kind of an equation could I set up in order to solve for X? Well, I'm going to take these two guys and I'm going to add them up. So X plus 14 plus AD, which is 38, and I am going to chop that in half. And that sum divided by 2 is going to be equal to IS, but IS I know is 5x minus 19. All right. What do you think the best way to solve this equation would be? Well, here's how I would start it. Since I'm dividing this whole expression here by 2, Okay, if I'm dividing by 2, in order to get this 2 out of here, I have to do the opposite of that. So what's the opposite of dividing by 2? Multiplying by 2. And if I multiply this side by 2, I can't do something to one side without doing it to the other side, so I am going to multiply this side by 2 also. And then boom, these 2's will cancel out. Now we're not dealing with fractions anymore, thank goodness. All right, so what am I left with on the left-hand side? I have x plus 14 plus 38, which I think is 52. And then over here, I have 5x minus 19 times 2. So I'm just going to distribute that 2 inside here. And I'm going to get x plus 52 equals 10x. And then 2 times negative 19 would be minus 38. All right. So it looks like I got variables on both sides of the equation. So I want to move them all to one side of the equation and move all of the constants to the other side of the equation. I would probably subtract x first from both sides. That's just how I would do it. And I get 52 equals 10x minus 1x would be 9x. And then bring down my minus 38. And now we have an easy little 2-step equation job. Plus 38. Plus 38. These will cancel, and I'm left with 9x equals 90. And last but not least, I would have to, I'm running out of room here, guys. I'm going to divide this side by 9 and divide this side by 9, and I'm left with x equals 90 divided by 9 would be 10. All right. Did we solve the equation, or did we answer what they were asking us? Let's read the question again. It says we need to find the measure of IS. No, we did not. We figured out x. So what do we do next? You got it. We got to take this guy and plug it in for 5x minus 19. All right, so that's just an easy little substitution. I get 5 times 10 minus 19. That's going to give me the measure of IS. So that would be 50 minus 19. And 50 minus 19 would be 31? I think so. IS equals 31. All right, not so bad, right? All right, we're going to finish off this lesson with 2 of your guys' favorite things. I have 2 proofs for you. Numbers 2 and 3 are proofs. I know you guys love proofs. All right. Number 2 says quadrilateral tray has coordinates of -7, 7, -2, 8, 0, 4, and -3, -1. All right, take a second and plot those. I am going to set down my camera and I'm going to plot them as well. All right, welcome back. Hopefully you have a trapezoid that looks just like mine, T-R-A-Y. Double check, make sure I plotted my points correct. I think I did. All right. Now, our ultimate goal here is to prove that this quadrilateral here is a trapezoid. So we got to think, what do I know is true about all trapezoids? Well, all trapezoids definitely have one pair of parallel sides. Okay? So, I know that if this is a trapezoid, that 2 of these sides have to be parallel to each other, meaning they would never touch. Okay? How do I prove that in the coordinate plane? How do I prove that 2 line segments or 2 lines in the coordinate plane are parallel? Well, if you were thinking that parallel lines have equal slopes, that would be absolutely correct, okay? So, I know for a fact that parallel lines have equal slopes. So if I can show that 2 of these lines have the same exact slope, that this is definitely a trapezoid. Okay, But I have to show, this is the part might be a little bit confusing. If I prove that one pair of sides are parallel, that's not enough. Because what if the other two sides were parallel too? Well, this wouldn't be a trapezoid. What would it be? If you're thinking parallelogram, you are absolutely right. All right? So, I know that if this is a trapezoid, one pair of sides is parallel and the other pair of sides is not parallel. So I have to figure out what is the slope of all four of these sides. And hopefully two are parallel and two are not. Right? So remember the slope formula. Okay? Slope formula is m, which is the letter that we use for slope, okay, equals y2 minus y1 over x2 minus x1. Okay? And the x's and the y's are the coordinates of the points. All right? So, we are going to, remember, with these coordinate proofs, guys, I like you guys to stay organized. So we are going to figure out what's the slope of TR. We're going to figure out what's the slope of RA. We are going to figure out what's the slope of AY. And last but not least, we have to figure out what's the slope of TY. All right, so we have all of our coordinates up here, okay? And now we can just plug them into the slope formula. All right, so the slope of TR, I would do 8 minus 7 over negative 2 minus negative 7. Well, 8 minus 7 is definitely 1, and negative 2 minus negative 7 is really negative 2 plus 7, which I think is 5. All right, so the slope of TR is 1/5. All right, let's move on to RA. Here are my two coordinates for R and A. So I would do 4 minus 8, y2 minus y1, over 0 minus negative 2. 0 minus negative 2. I think 4 minus 8 is negative 4. And I think 0 minus negative 2, remember minus and negative is really plus 2. All right, so 0 minus negative 2 would be over 2. And is this in simplest form? I don't believe so. So I would do negative 4 divided by 2, and negative 4 divided by 2 is negative 2. So the slope of RA is negative 2. All right. Let's move on to AY. Here are my coordinates for AY. So I would do negative 1 minus 4 divided by negative 3 minus 0. Okay. Negative 1 minus 4 is negative 5, and negative 3 minus 0 is negative 3. Now, here's the weird thing. No, not weird, but just a little review. Okay, if I look at AY, okay, AY, is this a positive slope or is this a negative slope? Remember from Algebra 1, if it's going from left to right, if it's going up, it's definitely a positive slope. Why do I have negative numbers here? Because this is not in simplest form. A negative divided by a negative is really positive. So the slope of AY is not negative 5/3, it's positive 5/3, because a negative divided by a negative is a positive. Let's recap really quick. So I have the slope of AY is 5/3. The slope of TR is 1/5. The slope of RA is negative 2. I have not proven that anything is parallel yet. Hopefully TY will match up with one of these slopes. Well, let's make a prediction. TY is probably parallel to which line? I think it should be obvious. I think that these two are probably my two parallel sides. Okay? Well, if this side is parallel to this side, and the slope of RA is negative 2, that means the slope of TY should also be negative 2. Let's check it out. Here are my coordinates for TY. Okay, so I'm going to do, let's see, y2 minus y1, so negative 1 minus 7. divided by -3 minus -7. And what do I get? -1 minus 7, I think, is -8. And -3 minus -7, or -3 plus 7, really, would be 4. I thought that this and this were going to match up. Well, I'm not done yet. -8 divided by 4 is good old -2. So, looking at my 4 slopes, do I have a trapezoid? Well, these two sides are not parallel. These two sides have the same slope, so they are parallel. Therefore, I definitely have a trapezoid. Now remember, with these coordinate proofs, I want you guys to come up with just one little conclusion statement that shows we knew what we were doing when we were setting up this problem. All right. So I always like starting with the word since. Since RA is parallel to TY and TR is not parallel to AY, then TRAY is a trapezoid. Not too bad, right? All right, last one. All right, given quadrilateral Josh is an isosceles trapezoid. And then my other piece of given information is OU and SA are altitudes. Remember this word? And remember this word, isosceles. Altitude and isosceles. We are definitely going to need to know what those mean if we are going to prove that the triangle JOU, get my highlighter out, JOU is congruent to HSA. If I'm going to prove that these two triangles are congruent, I definitely am going to need to know what altitude and isosceles means. All right, well, since this is a triangle proof using the properties of a quadrilateral, all right, who remembers what our first line of our proof is definitely, always, 1000% of the time? What is our first line going to be? Definitely the given information. All right, so I know I didn't give you guys too much room for this, so I am going to do this on a piece of paper. Hold on one sec while I get everything set up. I went ahead and I made my statements and reasons column, and I just transferred the given information into my table. All right, now I got to kind of pick this apart and figure out where am I going from here. Well, remember, our goal is to prove that the two highlighted triangles are congruent to each other. Well, let's think about it. There are 5 different ways to prove that two triangles are congruent. What are they? Well, we have side, side, side. We have side, angle, side. We have angle, side, angle. We have angle, angle, side. And last but not least, we have hypotenuse, leg. All right. So I have to hopefully prove that these two triangles are congruent by proving that either all 3 sides are congruent, 2 sides are congruent and the angle between them are congruent, or so on. All right, well, the way that we're going to do that is we need to pick apart this given information. All right, let's start with the first one. Quadrilateral Josh is an isosceles trapezoid. Well, what does that mean? If this is an isosceles trapezoid here, what do we know about isosceles trapezoids? Well, what do I know about isosceles triangles? Remember, it's the same thing. It means I have two congruent sides. Well, which two sides are congruent in this case? Pretty sure it's JO and SH. I know for a fact that since this is an isosceles trapezoid, JO is congruent to SH. Boom. There's our second statement. JO is congruent to SH. Why? How do we know that these two sides are congruent to each other? Which word told us that these two sides were congruent to each other? Good old isosceles. All right. So the reason that I know that those two sides are congruent is the definition of isosceles. Yeah, definition of isosceles trapezoid, let's put. Awesome. Boom, I got two sides out of the way. All right, let's see if I can prove anything else. Well, go back to your notes on isosceles trapezoids. What else did we absolutely know was true about isosceles trapezoids? If these two sides are congruent, what else do I have that's congruent? The two base angles, remember that? So I know for a fact that angle J and angle H are also congruent. Okay? And since it's the same exact reason, the definition of isosceles, I can just stick it right in with my second step. Okay? I know for a fact that angle J is congruent to angle H. And the reason would be the same thing, definition of isosceles trapezoid. So I got a side out of the way, or a pair of sides out of the way that are definitely congruent. I have two angles in these triangles that are definitely congruent. Okay, now I just need to prove one more thing. All right, so let's move on to our last piece of given information, that OU and SA are altitudes. What does altitude mean again? If I have an altitude, that means what? Who remembers? Altitudes create a special type of angle. And if you're saying, hey, Mr. Tracy, it's a right angle, you are absolutely correct. Okay? If OU and SA are altitudes, that means that angle JUO and angle HAS are definitely right angles. So let's put that into our statement of reason column. All right, we'll go 3. Angle JUO and angle HAS are right angles. How did I know that? How did I know that this angle and this angle were 90 degrees? That's what I'm going to have to put in my reason column. The definition of what word told me that these were right angles? Altitudes. Altitudes create right angles. Therefore, I know that JUO and HAS are right angles because of the definition of altitude. All right, well, I just proved that they're both right angles, but did I prove that they're congruent? Well, you guys might be saying, hey, Mr. Tracy, it's common sense. They're both right angles. Right angles are 90 degrees, therefore they are congruent. You are right, but we cannot just assume. So now I have enough information to say that angle JUO is congruent to angle HAS. So I'm going to stick that right in my statements column. All right. Angle JUO is congruent to angle HAS. Why is that true? Well, all right angles are congruent. All right, so now let's take a look at what we've proven so far. I have an angle, in a side, in that order. I have an angle, and a side in that order. So, am I going to use angle, side, angle, or angle, angle, side? Remember, the order matters. Now I have enough information to prove that triangle JUO is congruent to triangle HAS, and the reason is going to be angle, angle, side, angle, angle, side. And that's the last line of our proof. All right. Last but not least, triangle JUO is congruent to triangle HSA. And the reason is definitely angle, angle, side. All right. Okay, so attached to this assignment is a homework sheet. It's a couple of questions from different regencies. You guys can do that, and you are going to submit it to me by Tuesday. Remember, we are in the fourth quarter now. Okay, get the quarter off to a good start. Make sure you hand in that stuff on time. It's only 4 questions. They're all part 3s and 4 questions, so they require a little bit of work. But it's only 4 questions, and I'm giving you Friday, Saturday, Sunday, and Monday to do it. So you have 4 days. Do it over the weekend, hand it in early. This way I can give you feedback. And that's pretty much it about quadrilaterals. As always, shoot me a text on Remind or send me a message on Teams. I'll do my best to get back to you as quick as possible. Other than that, I hope you guys are staying safe and healthy. Make sure you wash your hands. And hopefully I see you again this year. See you guys.